Welcome to the Explainer. Today, we're going to build on a skill you already have, factoring out a GCF, and use it to tackle a whole new kind of factoring challenge. It's called factoring by grouping.
Okay, let's dive into this. We'll start with a quick GCF review, then we'll introduce our new puzzle, the four-term challenge. From there, we'll break down the grouping method itself. I'll also show you a really common trap involving negatives, and we'll finish up with a handy checklist to help you nail this every time. So first, let's just refresh our memory on the one skill that's really the foundation for everything we're doing today, factoring out the greatest common factor, or GCF. Remember, factoring is simply the reverse of the distributive property. So instead of multiplying to get a product, we're starting with the product and we're breaking it down into its original factors. The key is finding that GCF. Now, the OpenSex textbook defines it as the largest expression that's a factor of every single term. But really, just think of it as the biggest piece you can divide out of everything all at once.
Okay, so what happens when a simple GCF pull just doesn't work? What do you do when you run into a polynomial where there isn't a single GCF for all the terms?
Well, this brings us to a new kind of problem, and it requires a brand new strategy.
Take a look at this four-term polynomial. Is there a single number or variable that we can divide out of every single one of those terms? Nope. Our basic GCF method just won't work here.
So we need a new technique. It's called factoring by grouping, and here's the secret. It's really just a clever way of using that GCF skill you already have twice.
The process is a pretty straightforward three-step plan. You group, you factor each group, and then you factor one more time.
We'll start by simply putting parentheses around the first two terms and the last two terms. See how we've created two little mini problems to solve? Now, we just find the GCF for each of these pairs separately. For the first group, we can factor out an x squared. For the second group, we can factor out a 2. And this right here illustrates the magic of grouping. This is the aha moment. A common binomial factor, that whole x plus 3, has just appeared out of nowhere. See, this is what I meant. First, we factored the GCF from the pairs, and now we're going to factor out that new binomial GCF. So we just pull out that common factor, the x plus 3. And what's left over? The x squared and the plus 2. And those leftovers, well, they form our second factor. All right, there is one common pitfall we need to talk about. You have to be super careful when that third term is negative. In this example, from our source material, see that negative sign in front of the 2x? That is a huge warning sign to be extra careful. Now, what's really interesting here is this comparison. If you factor out a positive 2 from that second group, your binomials won't match. But if you factor out a negative 2, it flips the signs inside and boom, you get the matching binomial you need. So the crucial point here is that factoring out the negative GCF is what leads us straight to the correct final answer.
Okay, to wrap this all up, let's put everything into a simple checklist you can use every single time you see a four-term polynomial.
All right, here is your step-by-step guide. First, do you have 4 terms? Next, and this is super important, is there a GCF for all 4 terms? If there is, factor it out first. Okay, then you group the terms into 2 pairs. You factor the GCF from each pair, remembering to watch out for those negatives. Then ask yourself, do the binomials match? If they do, you're golden. Factor out that common binomial, and you can always check your work by multiplying. And that really illustrates the point. Mastering this skill isn't just about this one type of problem, it actually opens the door to even more advanced factoring techniques you're going to see very soon.